So just a review of what we did previously, we've been using antiderivatives to calculate the area between a curve and the x-axis. And so if I have a curve that looks something like this, and I'm looking between some points b and some points a, what I can do is I can take the antiderivative, so this is just some curve f of x. So I can take the antiderivative of that function and then subtract basically b subbed into there and then a subbed into there. And that'll give me the area between there. Basically, the antiderivative from b will give me the area from b all the way down to the y-axis. A will give me from a down to the y-axis, so if I subtract those, that'll be the area in between. Now this one's all above the x-axis, so this will solve as positive area. But if this curve dips below the axis, it'll still work, but we'll just end up with a negative value for each of those. So what we're going to look at today, though, just kind of the next kind of step on this one here. So when we're looking at two curves, what we'll do is we'll just solve for the area between or under each of those ones then individually, and then we can subtract them from each other. So if we have, say, one curve that's heading over top there, we'll call that one f of x. If I take the antiderivative of that, then I'm going to get this whole area under here. If I have a second curve, and so let's call this one g of x, if I take the antiderivative under there, I'll get this area overall. And so what we're going to do then is we'll take the area in green here, that's the area under f of x, and we'll just subtract out the area under g of x, and that should give us then this area in between those two functions. And so the area under f of x minus the area under g of x should be then the area between. Now the other way that we can do this is we can just create a new function, and it'll be essentially the same thing. Now it is important that f of x is above g of x. If we took g of x minus f of x, we get the same numerical value, but it will be negative. So because we're looking for a positive area, we are always going to be trying to make sure that the upper function then is the upper function all the way through. And so on the one we have, let's go back to the green again, where we have then this function f of x. We have our second function g of x below, and what we're looking for then is the area between them. Now, as we've done before, we just subtracted the two, and that gave us this area between them. The other way that we can do this is we can introduce a new function. So we're going to take a new function h of x, which is actually just the original function subtracted. And so if we do that, then we'll get another function, which will be just some combination of those two. So this is h of x, which is then just f of x minus g of x. And then if I take the area under here, these two areas will be the same. So the area between them and the area here, so this area A and this area A, those are going to be equivalent values there. So what this tells us then is we can basically solve for the antiderivative of f of x, give us the first area, solve for the antiderivative of g of x, solve for the second area, and then subtract them. Or, and this will give us the same value, we can subtract the original functions and then take the antiderivative of h of x, which is our new function, and then apply then the boundary conditions for those. And so then we can just take then the one antiderivative. Usually it's not too much longer or shorter one way or the other. If they have overlapping terms, this will tend to be a little bit shorter, but both of them will work kind of in all cases. All right, so we have our two curves here. So the top curve over here, this is our parabola there. So this will be our f of x equals 2x squared plus 3. And this will be our linear equation down here. G of x equals 2x plus 1. Now we have kind of two main ways we can do this. One is we can just solve for each antiderivative individually and then subtract them. Or we can come up with then a second method where we basically subtract the two functions first, come up with a new function, and then take the antiderivative of that one. So we'll run through both of those actually in this case just to show how those ones will work out. So first one just calls for method 1. And for method 1, we're just going to take each of those individually and find the area. So we'll find the area under the parabola, find the area under the linear graph, and then we'll subtract those. So starting with our parabola here, we have f of x equals 2x squared plus 3. Now these are just going to be polynomial functions, and so we can then, for our antiderivative, we can use then this equation over here, where we add 1 to the exponent and then divide the term by that new exponent. So here then, when we solve for the antiderivative of f of x, we'll end up then with 2/3 x cubed and then plus 3x. Now we do also have a plus c here, but we're always going to subtract that away, so you can include it, or you can typically just leave it out because it always disappears when we do our area calculations. So the area then, and this will just be the area under f of x, is just going to be then this antiderivative at our upper bound, and our upper bound is going to be 2, our lower bound is 0, so f of 2 minus f of 0. So we can put our values in. We're just going to put 2 into the antiderivative, 0 into the antiderivative, and then subtract the two values there. And so I'll have 2/3 times 2 cubed plus 3 times 2. Now I'm going to leave the c out because the two c's are just going to subtract. So we have our value here. Now I have an x cubed and an x, so this one here, f of 0, is just going to be 0. So I'll just jump straight to there. So when we find this area over here, we'll get 16/3 plus 6. And then of course minus 0, which doesn't change anything. So then we can do the same thing with our g of x. So we have g of x is equal to 2x plus 1. So then the antiderivative of that, so still using that polynomial function, I'm going to get 2x squared, and I'll divide by the 2, so those two just go away. And then plus 1 times x. I also again have the plus c there. Again, I'll put it in for this example, but we really don't need to put that in. So then the area that I have under g of x is just going to be then g of 2 minus g of 0. I'm just going from the same range there we had before. And so that then is going to give me 2 squared plus 2, and then minus again just that 0 for the g of 0 there. And so then this one overall is just going to give us 6. And then we'll just take the area between the two curves. So the area between will be then the area of f of x minus then the area of that g of x. Which you can see then is just 16/3 plus 6, and then minus 6, and so that will then just equal the 16/3 overall. Now the second method we have is we can come up with a new function, we'll call it h of x, where we just subtract the f of x from the g of x, and then we just take the antiderivative of that. So you obviously don't have to do both methods every time you're solving these, but just to give you then the two different methods then that we can use. So we're going to come up with a new function h of x, which will be then my upper function f of x minus my lower function g of x, and I'll just subtract those two functions from each other. So then I get 2x squared plus 3, and then minus. Now don't forget to put a bracket here because we do have to subtract both of those terms, and so for that minus g of x, you always really want to make sure you're putting in that bracket. So 2x plus 1, and so my h of x terms, I can just collect my terms here. The 2x squared is off on its own. I get a minus 2x, and I get plus 3 minus 1, so then I get a plus 2 for that. So then my antiderivative of that gives me the antiderivative of h of x is going to give me then 2/3 x cubed, again just using the polynomial rule. That'll give me then 2x squared all over 2, which will of course just go to x squared, and then plus 2x. Now I do have the plus c there as well, but again we're typically not going to be including then that plus c. So my area between those two functions then just becomes now h of 2, again our domain's the same, minus h of 0. So for these ones then here, I can just put my values in. So I get 2/3 times 2 cubed minus then just 2 squared plus 2 times 2. And then I'll be subtracting. Now for the 0, this will go to 0, this will go to 0, and this will go to 0. So I can then just put in 0 for that one overall. So then when we solve this one, we get 16/3 for that first term. We get minus 4 and then plus 4. And so we see we end up again with the 16/3 which we had originally.